Hello everyone. In our previous lecture, we have discussed in detail about the components of ER diagram. Now let us see about the extended ER features and case study for the ER diagram. The extended ER features are specialization, generalization, attribute inheritance and aggregation. First, let us see about specialization. An entity set may include subgroupings of entities that are distinct in some way from the other entities in the set. For example, consider an entity set person whose attributes are name, street and city. A person can be further classified into one of the following subgroupings, that is customer or employee. So an entity set person can be further represented as a customer or employee. Each of these person types is described by a set of attributes that includes all the attributes of the entity set person plus possibly additional attributes. For example, customer entity may be described further by the attribute customer ID and employee entity may be described further by the attributes employee ID and salary. This process of designating the subgroupings within an entity set is called as specialization. In ER diagram, specialization is depicted by a triangle component labeled ISA. The label ISA stands for easier and represents, for example, that customer is a person. Now, let us see about generalization. Generalization is the bottom-up design process which combines the number of entity sets that share the same features into a higher level entity set. For example, employee and customer both share the attributes name, street and city which are combined into higher level entity set called person. Specialization and generalization are simple inversions of each other. That is, specialization is the top-down approach and generalization is the bottom-up approach. And they are represented in the ER diagram in the same way. The terms specialization and generalization are used interchangeably. Next, we have attribute inheritance. A crucial property of the higher and lower level entities created by specialization and generalization is called as attribute inheritance. The attributes of the higher level entity sets are said to be inherited by the lower level entity sets. For example, customer and employee inherit the attributes of the person. Now let us see the ER diagram which illustrates the concepts of specialization, generalization and attribute inheritance. So here we have the entity set person whose attributes are person ID, name, street and city. This entity set can be further specialized into employee and customer. Employee has its own attribute salary and customer is having its own attribute credit rating. And employee can be further specialized into officer, teller and secretary. Officer has its own attribute office number, teller is having attribute station number and hours worked, and secretary is also having an attribute called hours worked. Now if we are coming from top to bottom, then it is called as specialization. If you are going from bottom to top, then it is called as generalization. So officer, teller, secretary can be grouped together to form a general entity called employee. Employee and customer can be grouped together to form a general entity called person. Now attribute inheritance. So here the employee entity set is having its own attribute salary. In addition to it, it can inherit all the attributes related to the person. So that is called as attribute inheritance. In the same way, customer inherits all the attributes of the person. In addition, it has its own attribute called credit rating. This is applicable for officer, teller, secretary also. So in addition to its own attributes, all these entities will inherit the attributes of employee, which is salary. So thus we have seen the concept of specialization, generalization and attribute inheritance. Now let us see about the aggregation. Aggregation is an abstraction through which relationships are treated as the higher level entities. There is a redundancy in this figure shown. Here every employee, branch and job combination in managers is also related to the works on. So we can see that all these three entities is connected to both works on as well as the managers. So this is the redundancy in this figure. So we can avoid the redundancy by aggregation. So aggregation means we are combining the common entities into one set by making it inside the rectangle, and after that the relationship, higher level relationship, is treated as one entity and it is connected to the lower level relationship. So works on relationship set is connected to managers relationship set. So this rectangle indicates that whatever entity sets applicable for works on is also applicable for the managers. So no need to draw additional lines for each relationship sets. Instead we can have the aggregation process like this. So this is the advantage of aggregation. Next we will see about the case study. So here we are considering the ER diagram for banking system. So this is the diagram. So here we can see that we have the entity set called customer. It is having the attribute customer ID, customer name, customer street and customer city. And this customer can be linked to the loan entity set through the borrower relationship because customer borrows the loan, and it can also be linked to the account entity set through the relationship depositor. Now we can see that loan has its own attributes, loan number and amount, and account has its own attributes, account number and balance. So we have one descriptive attribute for the depositor, which is access date, which indicates when the customer has recently accessed the account. This account can be further designated as the subgrouping savings account and checking account using the specialization concept. So this savings account is having its own attribute interest rate, and checking account is having the own attribute overdraft amount. So this also can inherit the attributes of the account, which is account number and balance. And we can see that loan is connected to the payment entity set through the identifying relationship loan payment. So here payment is called as weak entity set because it is not having the primary key, whereas loan is the strong entity set because it is having the primary key loan number. So here we have the discriminator for the payment entity set, which is payment number, which is underlined with the dashed line. And here double lines indicates the total participation for between the loan payment and payment entity set. That is at least one payment must be done for the loan. So it is payment entity set is totally participating in the loan payment relationship. But a customer might have a loan or may not have a loan, so that is what it is indicated as the partial participation. And here we have the arrowhead indicating that one, so that is one loan can have multiple payments. So that is what one to many relationship is also designated between these two entity sets. And loan is further connected through loan branch to the branch entity set. So branch entity set is having its own attributes, branch name, branch city and assets. So one branch can have many loans. So that is what indicated here with one to many relationship. And the customer can also be a employee in the bank. So that is indicated through the relationship cust banker and is connected to the entity set employee. So employee is having its own attributes, employee ID, dependent's name, employee length, start date, telephone number and employee name. So here dependent name is the multi-valued attributes because an employee can have multiple dependents, and employee length is the derived attribute because it is derived from the employee, that is attribute start date. And here we have roles, which is indicated at the top of the line. So employee is working for the bank, so he can be a manager or a worker. And cust banker is having the descriptive attribute type, so it indicates whether he is a customer or employee. So thus we have seen all the concepts of the ER diagram with this case study. So now we have understood the concept of ER diagram from this lecture. Thank you.